A single supertanker hull stretches longer than the Empire State Building laid on its side. It carries enough crude oil to fuel 1 million American cars for an entire month. And right now, dozens of these ships are moving through a strait just 21 miles wide, with the U.S. Navy running alongside them. So how does a vessel this massive actually work? How do you load 2 million barrels of oil, keep it from exploding, and push it through one of the world's tightest choke points? This is Directive 1, and we are going to walk through every stage. The Strait of Hormuz sits between Iran and Oman, a narrow corridor connecting the Persian Gulf to the open ocean. By recent estimates, roughly a fifth of all oil traded globally passes through it every single day, on the order of 17 million barrels. When tensions rise, every tanker in that lane becomes a target, and the U.S. Navy's convoy operations become the only thing between the global economy and a supply shock. The ships doing the actual work are called Very Large Crude Carriers, VLCCs. Each one displaces around 300,000 tons when fully loaded. Each hull is assembled in massive prefabricated blocks, some weighing over 500 tons each, in shipyards in South Korea and China. Here is where it starts. In a dry dock the length of 4 football fields, workers position the first keel blocks on the dock floor. Steel plates up to 32 millimeters thick are cut by automated plasma torches and rolled into curved panels at a dedicated plate shop. Those panels are welded into sub-blocks roughly the size of a 2-story apartment. Cranes lift each sub-block into position, and robotic welders stitch the joints with multi-pass seam welds rated to withstand deep-sea pressure cycles. The ship grows from the bottom up, block by block, until the entire hull, roughly 330 meters long and 60 meters wide, is assembled inside the dock. Every steel offcut goes back into the production line. Nothing is wasted. The double hull is one of the most critical engineering decisions in the build. There is no single skin of steel between the cargo and the sea. 2 complete hulls, inner and outer, run the full length of the ship, separated by a void space of roughly 2 meters, wide enough to walk through. If the outer hull is breached, the inner hull still contains the oil. That is why modern VLCCs can take a collision and stay intact. Once the hull is complete, the dock is flooded. The ship floats for the first time. Tugs pull it to an outfitting berth where the cargo systems go in. A VLCC does not carry oil in one giant tank. It carries it in 30 to 40 separate cargo tanks arranged in rows across the hull, port, center, and starboard, each individually valved and monitored. This subdivision keeps the ship stable as cargo shifts and limits damage if one tank is compromised. Then the piping goes in. The main cargo lines running along the tank tops are roughly 400 millimeters in diameter, wide enough for a person to crawl through. Submersible cargo pumps, 1 per tank, sit at the bottom of each compartment. During discharge, those pumps push oil upward through the cargo lines to shore connections at the manifold amidships. Each pump delivers roughly 2,000 cubic meters per hour. With all pumps running simultaneously, a full VLCC can discharge 2 million barrels in roughly 24 hours. Here is what most people never think about. Crude oil vapor mixed with air at the right concentration is explosive. An empty tank is more dangerous than a full one, so every VLCC runs an inert gas system continuously. Flue gas from the ship's boilers, mostly nitrogen and carbon dioxide with oxygen content below 5%, is scrubbed, cooled, and pumped into every tank at positive pressure. That 5% threshold is the critical number. Below it, the vapor-air mixture cannot ignite. The inert gas system monitors oxygen levels constantly, and if any tank reads above the limit, the entire loading operation stops. Engineers call this the first line of defense. It runs 24 hours a day. There is a lot of invisible engineering in that system dedicated entirely to preventing a catastrophe nobody hears about, because when it works, nothing happens. Now the engine room. A VLCC's main propulsion is a 2-stroke slow-speed diesel, the largest reciprocating engines built for commercial use. The MAN B&W and Wärtsilä engines fitted to modern VLCCs produce between 25 and 30,000 kilowatts. At sea, they burn roughly 200 to 250 tons of heavy fuel oil per day, depending on speed and conditions. That fuel, called HFO, is so viscous at room temperature it resembles tar. It has to be heated to around 130 degrees Celsius before it will flow through the injectors. The heat exchangers and purifiers handling this process run continuously from the moment the engine turns over to the moment the ship docks. Put yourself at the throttle for a second. A fully loaded VLCC takes roughly 3 miles to stop from full sea speed. You cannot brake, you cannot turn sharply. The entire navigation strategy inside the Strait of Hormuz is built around keeping the ship in the deepest part of the channel at all times, because the fully loaded draft, the depth of the hull below the waterline, runs to approximately 22 meters. In parts of the strait, the margin between the keel and the seabed is measured in single-digit meters. The loading terminal in the Persian Gulf is where this all comes together. Saudi Aramco's Ras Tanura terminal is one of the largest crude export facilities on Earth, capable of loading multiple VLCCs simultaneously. The loading arms, articulated steel pipes on the jetty, connect to the ship's manifold at the center of the vessel. Crude oil is pumped from onshore storage tanks through subsea pipelines to the jetty, then up through the loading arms at rates up to 20,000 cubic meters per hour. The tanks fill from the bottom, displacing the inert gas atmosphere upward through the vent mass. The entire 2 million barrel load goes aboard in 18 to 24 hours. The strangest part of loading is the precision required to keep a 300,000-ton vessel stable, as its weight distribution changes by millions of kilograms every hour. The chief officer manages a loading computer that models hull stress in real time, controlling the sequence in which tanks fill to keep shear forces and bending moments within the limits the shipyard specified. Get the sequence wrong and you can crack the hull, then the transit. Once loaded, the VLCC draws too much water to run at full speed. The engines throttle back to roughly 15 knots. The Navy escort positions destroyers and frigates in a screening formation around the convoy, with maritime patrol aircraft overhead and electronic warfare assets monitoring the entire electromagnetic spectrum of the strait. The tanker's own bridge team maintains a continuous radar and AIS plot, tracking every vessel within 20 miles. The 21-mile width of the strait sounds generous until you factor in the shipping lanes, the exclusion zones, and the depth restrictions. The usable corridor narrows to roughly 6 miles. Will convoy operations in the Strait of Hormuz become permanent? Drop yes or no in the comments, because the answer shapes global energy prices for the next decade. The passage takes roughly 3 hours at transit speed. On the far side, the VLCC enters the Gulf of Oman, picks up speed, and sets course for the U.S. Gulf Coast, 12,000 miles away. At 15 knots, that is 33 days at sea. During that transit, a crew of 25 to 30 officers and ratings runs continuous maintenance on the cargo system, the engine room, and the inert gas plant. Nothing stops. At the Louisiana offshore oil port, Loop, the VLCC moors to a single-point mooring buoy 12 miles offshore in the Gulf of Mexico. Discharge begins immediately. The same submersible pumps push crude through a flexible hose to the buoy, then through a subsea pipeline to onshore storage. 2 million barrels gone in a day. The ship rises 14 meters as it empties, riding high, light, almost ghostly above the waterline, and within 48 hours it is heading back toward the Gulf. The system never sleeps. From a plasma-cut steel plate in a South Korean dry dock to a refinery tank in Louisiana, one VLCC moves enough oil to heat 2 million American homes for a month through a 21-mile choke point, guided by engineering margins measured in single-digit meters. The scale of what it takes to keep that corridor open is something almost nobody stops to picture. Which mega-build should Directive 1 take apart next, and where are you watching from? Drop both in the comments. We read everyone. Title Sekitiak. How the U.S. Navy escorts 2 million barrel supertankers through a 21-mile choke point. Title End. Description. Inside the U.S. Navy's Hormuz convoys, how a 300,000-ton supertanker loads and moves 2 million barrels of crude oil. By the end, you'll understand every stage, hull assembly, inert gas systems, loading arms, and the 21-mile transit that keeps global oil flowing. Very Large Crude Carrier, VLCC engineering, Strait of Hormuz convoy operations, Saudi Aramco Ras Tanura terminal, Loop offshore port. A single VLCC carries enough crude to fuel 1 million American cars for a month, yet almost no one has seen what happens inside that hull. This video walks the entire process: prefabricated block construction in South Korean shipyards, double hull design, inert gas explosion prevention, slow-speed diesel engines burning around 200 to 250 tons of fuel per day, real-time hull stress loading computers, and the Navy screening formation that shepherds each ship through the narrowest usable corridor in global shipping. From keel blocks on a dry dock floor to discharge at the Louisiana offshore oil port, every stage, every number. Description: end. Wadresser intro, 21 miles, under intro end. Additional: Alt 1, how it's built. How a 300,000-ton oil supertanker is actually built inside a mega shipyard ALT-2, number scale, the ship that carries 2 million barrels through the world's most dangerous strait. ALT-3, country rivalry, world record. Why South Korea builds the supertankers that power the entire planet. ALT-4, with series tag, how the U.S. Navy moves 2 million barrels through the Strait of Hormuz. Directive 1, Mon, additional end. Cover. Aerial wide shot of a fully loaded VLCC supertanker underway in open blue water, shot from directly above and slightly forward. The rust-red hull stretches across nearly the full frame, dwarfing 2 small escort vessels visible at its flanks. The deck pipework and manifold amidships catch sharp sunlight. A faint haze of the Persian Gulf coastline sits on the horizon, bright midday light, high contrast between the dark hull and the white wake churning behind it. Cover end.